Next is question number 81, which says that if the direct common tangents of the circles x square plus y square equal to 1 and x minus 5 whole square plus y square equal to 4 intersect each other at point D and the transverse common tangents to them intersect each other at T, then dt is equal to, let us say these are the two circles and these are the direct common tangents on the two circles which are intersecting each other at point D. Now let us say we join the centers of both the circles which will also pass through the point D, and let us join these points also. Let us say this is C1, this is C2, and this is A and this is B, right? So we know the point C1 is 5, 0 and AC1 is equal to radius, that is 2, and the point C2 is 0, 0 and radius of the circle, that is BC2, is equal to 1. Now we know that this is a right triangle and this is also right angle. Hence we know that DC1A and DC2B, they both are similar. So we can say that DC1 upon DC2 is equal to AC1, that is 2 upon BC1, that is 1. So we can say that DC1 is equal to 2 times DC2. Let us say DC2 is equal to X. So we can say that C1, C2 will also be equal to X. That is, C2 is the midpoint of C1 and D. So we can say that the coordinate of D will be equal to minus 5, 0. Similarly, we will find the coordinate of point T. Let us again draw a diagram. These are the two circles and these are the transverse common tangents on the two circles. Let us say this is C1 and this is C2, and let us join these points, and when we join C1, C2, then it will pass through this point, that is T, and let us say this point is P and this is Q. Now we know that triangle C1 PT and triangle C2 QT, they both are similar because these two angles are equal because they are vertically opposite, and this angle is equal to this angle. So we can say that angle C2 TQ is equal to angle C1 TP. Also angle C1 PT is equal to angle C2 QT. Hence both these triangles are similar. So we can say that C1T upon C2T, this will be equal to C1P, that is 2 upon C2Q, that is 1. So T is dividing C1 C2 in the ratio 2:1. Now we know the coordinate of C1, that is 5, 0, and we know the coordinate of C2, that is 0, 0. So by section formula we can find the coordinate of T, that is 2 into 0 plus 1 into 5 upon 3, 2 into 0 plus 1 into 0 upon 3, that is 0. So now we know the coordinate T and coordinate D. Hence we can find the value of dt equal to minus 5 minus 5 by 3 mod. So this will be equal to 20 by 3 units. Therefore the correct answer will be option number 3. Next is question number 82. If the hyperbolas xy equal to a square and x square minus y square equal to b square intersect at right angles, then the number of possible ordered pairs a, b is. Let us differentiate this equation xy equal to a square. We will get x into dy by dx, let us say that is y dash, plus keeping y constant, differentiation of x is 1. So this is equal to 0. So from here we get that y dash is equal to minus y upon x. Similarly, differentiating second equation, we will get 2x minus 2y into y dash is equal to 0. That is x is equal to y into y dash. So from here we get that y dash is equal to x upon y. So from equation 1 and 2 we see that m1 into m2 is equal to minus 1 for any values of a and b. The two hyperbolas are intersecting each other at right angles, right? Therefore, we have infinite number of values of a comma b. Hence, the correct answer will be option number 4. Next is question number 83. That is, the equation of a line which is tangent to the parabola x square equal to 4 times y plus 2 and normal to the parabola y square equal to 4x is. We know the equation of normal to the parabola y square equal to 4x is y equal to minus tx plus 2at plus at cube at point at square comma 2at. Now here the value of a is 1. So the equation of normal is y equal to minus tx plus 2t plus t cube at point t square comma 2t. Now this equation is tangent to this parabola. Therefore, putting y equal to this, we will get x square equal to 4 times y plus 2, that is minus tx plus 2t plus t cube plus 2. Now we will make quadratic in x, that is x square plus 4tx minus 8t plus 4t cube plus 8 is equal to 0. Now this will give us discriminant d equal to 0 because it is a tangent to this parabola, so it will be intersecting it at only one point. Therefore d is equal to 0 will give us 16t square plus 4 into 8t plus 4t cube plus 8 equal to 0. Now cancelling 16, we will get t square plus 2t plus t cube plus 2 equal to 0. That is t cube plus t square plus 2t plus 2 is equal to 0. Now here we can see that putting t equal to minus 1, we will get minus 1 plus 1 minus 2 plus 2 equal to 0. So making its factors, we can write t plus 1 into t square plus 2 equal to 0. So the only real value of t is minus 1. Therefore, the equation of line will be y equal to, putting t equal to minus 1, we will get x minus 2 minus 1. So the equation of the line is y equal to x minus 3. Hence, the correct answer is option number 3. Question number 84 says that the eccentric angle of the point at which the equation of the tangent to the hyperbola x square upon 4 minus y square upon 9 equal to 1 is 3x minus y equal to 3 root 3 is. Now, the equation of tangent to the hyperbola at the point 2 secant theta, 3 tan theta is x upon 2 into secant theta minus y upon 3 into tan theta equal to 1. Now comparing this equation with 3x minus y equal to 3 root 3, the coefficients will be in proportion. Hence we can say that secant theta upon 2 into 3, that is 6, is equal to tan theta upon 3 equal to 1 upon 3 root 3. So we can say that cos theta is equal to root 3 upon 2 and tan theta is equal to 1 by root 3. So the value of theta will be equal to 30 degrees, that is pi by 6. Hence, the eccentric angle of the point will be pi by 6. That is correct answer is option number 2. Next is question number 85, which says that consider the equations of lines L1, that is x plus lambda y plus lambda 1 equal to 0, and L2, that is x plus mu y plus mu 1 equal to 0. If lambda mu 1 is equal to mu into lambda 1, then the number of intersection points of L1 equal to 0 and L2 equal to 0 is. See, we know that for any two equations ax plus by plus c equal to 0 and px plus qy plus r equal to 0, if a upon p is equal to B upon Q is equal to C upon R, then the two lines are collinear. Therefore, we will have infinite points of intersection. Also, if the slope of the lines are equal, that is A upon P is equal to B upon Q is not equal to C upon R, then the two lines are parallel. Therefore, we have 0 points of intersection. And in the other case, that is A by P is not equal to B upon Q, then the lines will be intersecting at one point. So let us solve this question based on this theory, right? So here we can say that ratio of coefficient of x is equal to 1 upon 1 and the ratio of coefficient of y is equal to lambda upon mu and ratio of constant term is equal to lambda 1 upon mu 1. So here, which is the case? This is not equal to this. Therefore, this is the third case. But here it is given that these two are equal. So these two lines will be intersecting at one point. Therefore, the correct answer will be option number 2.